Greetings, students. This is Mr. Torgerson. We're going to discuss practice test 4-1 today. Let's begin. Question 1. Simplify the square root of 600. So what I'm looking to do here is to reduce this root into a perfect root and a non-perfect root, or a composite root and a perfect square. So I notice this ends in double zero. Anything that ends in double zero automatically divides by 100. So I will start off by writing this as 6 times 100. The 100 here is a perfect square root. It becomes a 10 when it roots. Now the 6 is a composite root. It's 2 times 3. Because 2 and 3 are both not perfect squares, the 6 will not be reducible here. In other words, when I reduce this root, I'm going to write this as the square root of 100 times the square root of 6. And my answer will be 10 times the square root of 6. Question 2. 63. So 63 divides by 9 7 times. It also divides by 3 31 times. So let's say I chose 3 and 31. Well, 3 and 31 are not perfect roots in and of themselves. They're composites. But 31 is 30. But 31 is reducible into, 21 is reducible into 7 times 3. If we did, however, choose 9 and 7, then we would get directly to the perfect root. 9 becomes a 3, and its non-perfect counterpart, 7. 3 root 7 is my finished answer here. So again, the concept of these two questions is to take the perfect root out from the expression and to leave the unperfect root underneath, or the composite root underneath the radical. All right, question 3. Question 4, factoring. So here I have a negative 13 as my value of b, and the a is 1 and c is 30, so a times c is 30. I'm trying to make that 13 from the 30 using the factors of 30. So 30 is either 6 times 5, but 6 and 5 will make 11 when they combine together through addition, or it's 10 and 3. Well, 10 and 3 could be 13 if they're both negative. So I will use a negative 10 and a negative 3 here as my two factors. Because a is 1, I don't have to worry about dividing by a because 1 into anything is always 1. So my factors are in fact just the minus 10, x minus 10, and the minus 3. I can verify my work by multiplying these out. Negative 3 times negative 10 is positive 30. Negative 3x, negative 10x, that's negative 13x. And x times x is x squared. The other sample here, 40, is the value of b. Excuse me, the value of a times c is 40. And the value of b is 13. So 40 is either 4 times 10, but 4 and 10 would make, they wouldn't make 13, they'd make 14. Or it's 8 and 5. Well, 8 and 5 would be 13 if they were added together. So 8 times 5 is 40, and 8 plus 5 is 13. Now, because a is 1, once again, when I divide these by 1, I don't have to modify them at all. So my factors are, in fact, just the x plus the 8 paired with the x and the 5. I can verify my work. 8 times 5 is 40. 5x plus 8x is 13x, and x times x is x squared. Question 5, graphing lines. You can put these in slope-intercept form, both of these lines, and I would highly recommend that because on this one, the x-intercept is not integer. So this one is, in fact, the easier question here, the question 6. So I will graph this one first. The slope here is 9, and the point, or the y-intercept, is 0, 5. So I will start at 0, 5 as a coordinate. It has a slope of 9, so I would go up 9 over 1, but I can't go up 9 over 1 on this graph because I can't go up 9. The paper's not big enough. So I'm going to go down 9 and left 1, which is the same as going up 9 and right 1 because it still has a slope of up 9 to right 1. And there's the graph of my line with a slope of 9 and a point of 0, 5. The next one here, I'm going to move the 7x over with the 25. 5y equals negative 7x plus 25. I'm going to divide everything by 5. The reason I'm doing this again is because the 7 doesn't divide by 5 evenly here, so getting the x-intercept is not quite efficient on this question. So y is negative 7/5 x plus 5. So my slope here is negative 7/5. And my point is 0, 5. I'm going to start at 0, 5. The y-intercept, and then go down 7 over 5. So down 7 and over to the right 5. A negative slope will point in this direction, always. And a positive slope will point in this direction, always. All right, next questions. Name the polyhedron and write down how many faces, vertices, and edges it has. So this is a pyramid with a 1, 2, 3, 4, 5, 6-sided base. So it's a hexagon pyramid. If it had a triangle bottom, it would be a triangular pyramid. If it had a rectangle bottom, it would be a rectangular pyramid, so on and so forth. The faces. The faces, again, are the sides, or the number of polygons that the shape contains. So it has the hexagon on the bottom, plus 6 triangles. So it's got 7 faces, 1 hexagon and 6 triangles. If it helps you, you can write down the shapes here next to this. 1 hexagon and 6 triangles. All right, the edges, the vertices. The vertices, again, are the points. So it's got the 6 points on the bottom from the hexagon and then the point at the top, 8. Now the edges here, you can count them or you can use Euler's theorem to find them. Remember, the faces plus the vertices equals edges plus 2. So a good way to check your work is you can count the edges and then you can verify that you've done it properly by doing faces plus vertices, in this case it would be 15, and verifying that in fact that it is the number of edges plus 2. So when I look at the edges again, these are the segments that connect the vertices together. So there's 1 in the back, 2, 3, 4, 5, 6. So there's 6 around the side of the shape, and then there's 7, 8, 9, 10, 11, 12. 12 edges. So now I've got a problem. I did this on purpose. Because the faces and the vertices make 15, but the edges plus 2 only makes 14. Can you spot what I did wrong? There are in fact not 8 vertices. There are only 7 vertices on this. There's the 6 on the bottom and then the one at the top, point. And again, you should look at this and you should say faces plus vertices, that's 14, is equal to edges plus 2. That's also 14. That's a good way to verify your work. All right, question 8, same question. This is a cube or a square prism. If you want to call it a square prism, that's fine as well. The faces here, it's the same amount of faces as there are in a box. There's the front, the back, the left, the right, the top, and the bottom. Front, back, left, right, top, and bottom. So there are in fact 6 faces here. The vertices, the corners, there's 4 on the top and 4 on the bottom, 8. And the edges. Again, the faces plus the vertices should be the edges plus 2. So this once again makes 14, so it should have 12 edges, and I can count them. 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the bottom, and then 4 connecting the top to the bottom. And I should again verify that, in fact, 6 plus 8 is 14. 12 plus 2 is also 14. So the faces plus the vertices is always equal to the edges plus 2. And that's what I'm asking you to do on question 9 and 10 as well. The faces plus the vertices should be the edges plus 2. So f plus 13 equals 22 plus 2. Again, the equation I'm using here is faces plus vertices equals edges plus 2. So 22 plus 2 is 24. And when I take 13 from 24, I get 11. There are 11 faces here. 11 plus 13 is 24. 22 plus 2 is also 24. On the next question, the faces, 8, plus the vertices, 13, should equal the edges, which I don't know, plus 2 as well. 8 and 13 is 21. and subtracting in this case 2 from 21, there are 19 edges, and once again I can check my work. 8 plus 13 is 21, and 19 subtract, that's 19 add 2 is also 21. The faces plus the vertices will always be equivalent to the edges plus 2. Alright, next item, we're going to talk about surface area now. Surface area of the different shapes. So we're going to start off with the rectangular prism and the triangular prism. So the rectangular prism, surface area of the rectangular prism, we're going to do 2 times the area of the base. So for these two, questions 11 and 12, we're doing 2 times the area of the base plus the lateral area. So you should organize your work on these two questions by writing down the height, which is how tall or long the shape is. So in this case, I'm going to call the height 11. Followed by the perimeter of the base. The base that I'm using is not the height, it's the base of the shape, the top and the bottom of the shape. In this case, the top and the bottom are the squares. The squares are the top and the bottom. So the perimeter of these squares is 5 plus itself 4 times, 20 meters. Lateral area is the height times the perimeter. So 11 times by 20, 220 square meters. Next item I have is the area of the base, which is the base 5 by 5, 25 square meters. And then the finished answer here, the surface area is equal to 2 times the base plus the lateral area. 2 times 25, which is 50, plus 220. So 50 and 220 is 270 square meters for question 11. That's the organization of the work that I should see on this, as well as question 12. So question 12, we're doing the same work. The height here, again, is the distance between the bases. The bases are triangular. So the height here is 6 centimeters. The perimeter is again, the triangular base, how long it is around it. So it's 3, 4, and 5 added together in this case. 3 plus 4 plus 5 for a total of 12 centimeters. The lateral area, again, is always equal to the height times the perimeter. 6 times 12. In this case, it's 72. The area of the base of a triangle. Half the base times the height on that triangle. So half of 3 times 4, which is 6 centimeters. And then again, for the surface area, we take 2 times the area of the base because there's 2 bases. And then we add in the lateral area. 2 times 6 is 12, plus 72. This is a total of 84 square centimeters for its surface area. All right, so there's our prisms, rectangular and triangular prisms. Next items, we have the cylinders. They work the same way, 2 times b plus the lateral area, 2 times the area of the base plus the lateral area. So this time, I'm going to take my height of 8 kilometers. My perimeter is the circumference of the circle, so I can call that C instead of P if I want, or I can call it P if I want to as well. So this perimeter is the circumference of the circle. So that is 2 times R times pi, so this is 8 pi in circumference, or perimeter. My lateral area, again, is H times P, or H times C in this case. 8 times 8 pi, 64 pi. That is in square kilometers now. These are all in kilometers. This last one's in square though, kilometers. The area of the base is pi times r squared. Pi times r squared. So in other words, it's pi times 4 squared, 16 pi. And then to get that, the surface area, I will take 2 times the base, 2 times the area of the base, so 2 times 16, which is 32 pi, plus the lateral area, 64 pi. So 32 and 64 is a 96 total in terms of its area, square kilometers. The next one is also a cylinder, so it works the same way. Again, the height is the connection between the circles here, so the height is 6, not 10, 6 miles. The circumference is 2 times r times pi, 2 pi r, circumference or perimeter of a circle. So this will be 20 pi, and circumference, and this is in miles. The lateral area, the height times circumference, or the height times the perimeter of the circle. So 6 times 20 pi, 120 pi square miles. The area of the base, pi times r squared, or 100 pi square miles. And again, surface area is equal to 2 times the area of the base plus the lateral area. So surface area is equal to 2 times 100 pi plus 120 pi. So 200 plus another 120 is 320 pi square miles. Now you can write these two questions, questions 13 and 14, in terms of pi, as I've done, or you can multiply them out and give a decimal approximate. Either answer will be acceptable in terms of your answers here. All right, next questions. We have the cones and the pyramids. So the cones and the pyramids have only one base. So rather than doing the 2 times the area of the base plus the height, we just do 1 times the area of the base. We just take the area of the base plus the lateral area here, in other words. So on this first cone, it has the same items. We do need to find the heights of the cones based on the given lengths. So I may label these heights for you. Actually, no, we don't need the heights. We need the slant heights. We're using the slant heights here with these cones since we're doing surface area. Sorry, guys. So we're going to start off with the, again, labeling the perimeter of the shape. Perimeter is equal to 2 times r times pi. So in this case, r is not 8 because 8 is the entire length across. R is actually only 4. So the perimeter here is 8 pi. And then we're going to do the lateral area by taking the perimeter times the height once again. Now when we do the lateral area of a cone, we actually divide that by 2 because we don't want double that length around it when we do it in a cone. We only want half of it. So I'm going to take this 8 pi, and I'm actually going to divide it. I'm going to multiply it by the 10.8, but I'm actually going to divide that by 2. And again, I'm dividing that by 2 because it's a cone instead of a cylinder, a full cylinder. So here we are going to use a calculator to evaluate this number. 8 pi times 10.8 divided by 2. 135 and 72 hundredths. We can round to the nearest hundredths. That is my lateral area. The area of my base is pi r squared. So pi times 4 squared, 16 pi. And then once again, to get the surface area of the cone, I can take the area of the base plus the lateral area. I'll take 16 pi, and I'll add in the 135 and 72 hundredths. Because I used decimals on the lateral area, I'm going to finish my answer here as a decimal for the surface area as well. All right, so I have this 135 and 72 hundredths plus 16 pi. Finished answer 185 and 98 hundredths. And that is in square inches. All right, next item. The perimeter of the circle here. 2 times r times pi. Well, that's just pi, because the radius here is just 1. So 2 pi for that circle. Lateral area. Perimeter times slant height. 2 pi times 3.2. We're going to divide that again by 2 because it's a cone instead of a cylinder. So instead of being a full cylinder, it's a cone. So I will do that in the calculator once again. 2 pi times 3.2 divided by 2. Looks like I erased it. 2 pi times 3.2 divided by 2 is 10 and 5 hundredths in terms of my lateral area. Approximately 10 and 5 hundredths. These are all in yards and square yards. So this one was in yards and square yards. The area of the base is again pi r squared. So pi times 1 squared is just pi. So for my surface area, I will have pi, which is the area of the base, plus the lateral area, plus 10 and 5 hundredths. So I'm going to add to this 10 and 5 hundredths I already have in my calculator. I'm going to add the value of pi, 13 and 19 hundredths. This is in square yards. All right, the pyramid. So the pyramid, again, just like the cone, the pyramid only has one base, but we still do the perimeter of the base. So the perimeter of the base here again is the bottom, the square in this case, and in this case it's the triangle. So this base has a perimeter of 9 times 4, 9 plus itself 4 times. Or in other words, it's got a perimeter of 36 inches. The lateral area, in this case we are also going to divide by 2 to get the lateral area because we're taking half, because it's a pyramid instead of a cylinder or prism. Because it's half, the lateral area is half of the corresponding prism it goes with. So I am going to multiply the perimeter times the height, 10.1, 36 times 10.1. But once again, I'm dividing this by 2, cutting it in half to get the actual appropriate value. So 36 times 10.1, and then dividing that in half yields 18, is 181 and 8/10. So that is the lateral area in square inches, 181 and 8/10 square inch. The area of the base here is the 9 times 9, length times width of a square gives the area, so 81 square inches. And again, because I'm doing a pyramid, I only have one base. I don't have the top and bottom of the pyramid. I just have the bottom of the pyramid. So to get the surface area, I'm just going to add that base, 81, with the lateral area, 181 and 8/10. So I'll take that 181 and 8/10 and I'll add 81 to it on my calculator here, and I'll get 262 and 8/10 in terms of my surface area. And this is in square inches. All right, next one, this triangle. The perimeter of the triangle, again, is the side lengths added together, the 3 sides. So all 3 of these sides are labeled with 7, the side lengths on the bottom here. So my perimeter is 21. In this case, it's in feet. The lateral area is, again, the perimeter times the height, slant height, divided in half. Because, again, a prism is half of the corresponding cylinder, or, excuse me, a pyramid is half of the corresponding prism. So 21 times 7.3, so divided by 2, is 76 65/100ths. So my lateral area is 76 65/100ths. This is in square feet. The area of the base is the area of that triangle on the bottom, so I'm going to do the area of a triangle. For area of a triangle, you do half of the base times the height, so half of 7 times 6 1/10. 1 divided by 2 times 7 times 6.1. 21 35/100ths is the area of the base. And again, for my surface area, I'll take that area of the base, 21.35, and I'll add in the lateral area, 76.65. So that 21.35, adding in 76 65/100ths for a total of 98. This is in square feet. All right, volume. Area of the base times the height. Volume equals B times H for these two. So the area of the base here on this one, we would call the bases the squares, which in this case the squares are 6 by 5, 30 square centimeters. The height here is 2, or in other words the depth. So 30 square centimeters times them by 2 will yield the volume 60 cubic centimeters. And then similarly for the cylinder, we take the area of the base times the height as well. The base is pi r squared for area. So pi times 3 squared, 9 pi is the area of the base here, with a height of 12 centimeters. So 9 pi timesing by 12 will yield the volume of this particular cylinder. 108 pi cubic centimeters. And I hope this helps. Keep in mind, I'm not going to be here for the test. You're taking the test in class. Do your best. I will have it graded by the time you get back to hand back to you. Good luck.